Hello friends, welcome to Learner's Planet. Friends, in this session, we will discuss how to find remainders in the division of very big numbers. Such division even can't be done on calculators. These type of questions are regularly being asked in CAT and other MBA entrance examinations. Friends, there is no shortcut to success. Similarly, there is no shortcut in mathematics. These are generally logical or smart ways to deal with the problems. So don't try to memorize so many things as you won't be able to recall whenever they are required. You need to work on logics to deal with mathematical problems. So you should try to improve or enhance your logical thinking and skills. Then math will be definitely a fun for you. Now let's see what's there for you in today's session. Friends, let's begin with the first concept. Here, what will be the remainder if d is divided by 13, where d is the multiplication of 27, 28, 29 and 30. Friends, if this sort of questions are asked in any competitive examinations, the aspirants are not expected to do this multiplication, then divide by that multiplication by 13, then they have to find out the remainder. Definitely there must be some logic, because all these sort of examinations we have time constraint. So if we do this problem by manual methods, will be taking more than 10 minutes to solve it. Okay, so there must be some logic, some algebra, some techniques behind this. So let's begin to see what the technique can be. Okay friends, now here d is 27 into 28 into 29 into 30. We have a number 26 that is closer to all these numbers. So let's break the number into a multiple of 13 and its remainder. Now, if 27 is divided by 13, we'll be getting the remainder as 1, since 27 is 26 plus 1. Similarly, if we divide 28 by 13, we'll be getting the remainder as 2, since it is 26 plus 2. Then it is 26 plus 3, and then it is 26 plus 4. Okay, so if we multiply all these numbers, all the numbers or all the components will be divisible by 13 except the product of 1, 2, 3 and 4. How it is possible? Let's do it through algebra. Suppose I have a number ax plus 13. Ax plus maybe b and cx plus d. Okay. This expression, if I wish to divide by x, then what is the remainder which I'll get? Let's calculate. So it's let's multiply the numbers. Let's multiply the expression. It's acx square plus bcx plus adx plus bd. Now, if I wish to divide the entire expression by x, okay, so this term is multiple of x, so you won't be getting any remainder. Even this term is multiple of x, you won't be getting any remainder. Similarly, this term is also multiple of x, so we won't be getting any remainder. We'll be getting remainder as bd only. Okay, so the similar case, if we apply over here, so if we are going to multiply all these terms, we'll be getting the remainder as 1 into 2 into 3 into 4. Friends, there is a fantastic algebra behind this concept. So once you learn that algebra, once you grasp that algebra, then every time you need not write the expression like this. I'm just writing it for the sake of clarity. Okay friends, so I can take one more example. Let's wait. Friends, here I am having x plus y whole square. Now what x plus y whole square is? X square plus 2xy plus y square. So if this expansion, if I divide it by x, what is the remainder that I'll be getting is, this term is multiple of x, this term is multiple of x, so I'll be getting remainder from y square only, that is this, that means y square. Similarly, if I write x plus y whole cube, it will be x cube plus 3x square y plus 3xy square plus y cube. Similarly, if I divide x plus y whole cube by x, from here I won't be getting any remainder, from here I won't be getting any remainder, from here I won't be getting any remainder, I'll be getting remainder from here only. If I put minus over here, then also doesn't matter. So I can x minus y whole square, that is x square minus 2xy plus y square. So I divide it by x. Further I'll be getting remainder from this portion. Similarly, x minus y whole cube, it will be x cube minus 3x square y plus 3xy square minus y cube. So I'll be getting remainder from this part only. So it's very simple, friends. Doesn't matter the power is 2, 3, 4, 5, 6. If we give the expansion to this polynomial, we will be getting the remainder from this extra part only. Let's expand this. Now suppose I have a number x plus y raised to n, and if I wish to divide this expression, I have this is a polynomial. If I wish to divide this expression by x, the remainder will be y raised to n. The remainder will be obtained from y raised to n. Sometimes this y raised to n can be bigger than x, then further we have to give it a breakup. Okay friends, now if it is x plus y raised to n, then we'll be getting the remainder from y raised to n, and if it is x minus y raised to n, then we'll be getting the remainder from minus y raised to n. Now it depends upon n. If it is an even number, then minus sign will not be there, and if it is an odd number, we'll be getting negative signs. So application of this will be taking in with some examples. Okay friends, so this is actually the concept of binomial theorem, but as such we don't have to learn binomial theorem. It is simple algebra which is only required to solve these sort of problems. So let's take some examples. Now let's take the first case. Let's divide d by 13. So 27 is 26 plus 1, it is 26 plus 2, it is 26 plus 3, and it is 26 plus 4. So as explained, what I'll be getting as remainder is 1 into 2 into 3 into 4. So 1 into 2 into 3 into 4, that is 2 3s are 6, 4s are 24. Since 24 is bigger than 13, so it cannot be remainder. So let's divide 24 by 13 and find out the remainder. So if 24 is divided by 13, we'll be getting the remainder as 11. Okay friends, it's so simple. Let's take more problems. I hope you are clear with the same. Now suppose I am having an expression, maybe a multiplication, that is suppose x is equal to 9 into 10 into 12 into 13 into 14. Okay, now I have to find out the remainder if I divide x by 11. So let's do it quickly. I will not be writing as a breakup of 11 and its remainder. Let's do it directly over here. So if 9 is divided by 11, the remainder will be either 9 or minus 2. So I'm just writing remainder over here, it's minus 2. Here it is minus 1, here it is 1, here it is 2, and here it is 3. So let's multiply all the remainders quickly. I'm having 2 minus, that will turn it to positive. So it's 2, 2's are 4, 3's are 12. So what I'll be getting remainder as 12, but remainder cannot be 12, so it will be 12 minus 11. That's it. That's 1. So if x is divided by 11, the remainder will be 1 only. It's so simple, friends, and you can save time if you cut it directly like this. Okay. Now suppose I'm having a number, say 4 into 5 into 6 into 8 into 9, and I wish to divide this number by 7 and wish to get the remainder. So it's let's divide it by 7. So here it is minus 3, it's minus 2, it's minus 1, it's 1, and it's 2. So since there are 3 negatives, I have to put one negative over here. Then multiply the remainders as in previous problems. 3 2s are 6, 2s are 12. Okay, now 12 cannot be remainder if we divide the expression by 7. So if 12 is divided by 7, the remainder will be 5. So I'm already having a negative over here, but since even the negative cannot be remainder, so in this case the remainder will be 7 minus 5, that's 2. Okay friends, it's so simple. Let's do some difficult problems now. Now let's see a series of questions. Here we have been asked what will be the remainder in the following divisions, or what should be deducted from the following so that they will be completely divisible by the given number, or what should be added to the following so that they will be completely divisible by the given number. That means a single question can be asked in 3 manners. Okay, here we have to calculate the remainder directly, it can be asked. Then what we have to add to the dividend to make it divisible by 9, then what we can deduct from the dividend to make it divisible by 9. So let's see. First of all, we should find out the remainder. Now here we have been given 1215 raised to 78, and we have to find the remainder if it is divided by 9. Now friends, what is the divisibility test of 9? I hope you may be able to recall that. It is the sum of digits should be divisible by 9. So let's do this. What will be the remainder in this case? Let's first divide 1215 by 9. Now 1215 into 1215 into 1215, 78 times. That means in each and every case, whatever is the remainder, the remainders will be multiplied as in the previous case. Then we have to find out the final remainder. Now let's begin. So it's what will be the remainder in if 1215 is divided by 9? Let's see. It's 1 plus 2, that is 3, plus 1 4, plus 5 9. Oh, this 1215 is already multiple of 9. So in this case we won't be having any other remainder except 0. So the problem is pretty simple. You'll be getting the remainder as 0. No worries, no big calculations. Let's take another problem. Now in this case we have to find out the remainder when 3 raised to 42 is divided by 4. Now what is the number that is closest to 4 and 3? So I can write this expression as 4 minus 1 raised to 42. Okay friends. So it's 4 minus 1 raised to 42. If it is divided by 4, then in this expansion, that is 4 minus 1 raised to 42's expansion, each and every term will be multiple of 4. So we'll be getting the remainder through minus 1 raised to 42 only. That is minus 1 raised to 42. So minus 1 raised to 42 will be 1 only. Okay friends, so it was so simple. We just have to find out a number that is closer to 3 and 4 both. So it's 4. Now in this case 3 raised to 43 is divided by 4. So let's find the number. So it's 3 raised to 43 can be written as 4 minus 1 raised to 43, and if it is divided by 4, the remainder will be minus 1 raised to 43. So since there is an odd power to negative number, so we'll be getting minus 1. Now remainder cannot be negative, so the final remainder will be 4 minus 1, that is 3. So if 3 raised to 43 is divided by 4, we'll be getting the remainder as 3. It's very simple, friends, and we can do it, the problems, this type of problems in seconds. Now let's see this problem. What will be the remainder if 7 raised to 84 is divided by 50? Now friends, we have to find out a number which is there in the power of 7 and which is closer to 50. So the same number can be 49. So what we do is we try to convert 7 raised to 84 in the power of 49. Since 7 square is 49, 7 raised to 84 can be written as 49 raised to 84 by 2. That is 49 raised to 42. Now if 49 raised to 42 is divided by 50, what will be the remainder that we have to calculate? Now 49 can be written as 50 minus 1 raised to 42. If it be divided by 50, what is the remainder we'll get is minus 1 raised to 42, that is 1 only. So if 7 raised to 84 is divided by 50, we'll be getting the remainder as 1. Okay friends. Now in this case, what is the remainder if 7 raised to 84 is divided by 342? Further, we have to find out a number that is there in the power of 7 and which is closer to 342. So friends, you'll be able to recall that 7 cube will be 343. So what I can do is 7 3 into 28. I can write 84 as 3 into 28. So it is 7 cube raised to 28, and 7 cube is actually 343. So it's 343 raised to 28. Now 343 raised to 28, I have to divide it by 342 and find out the remainder. Now 343 can be written as 342 plus 1 raised to 28. Now if this expression is divided by 342, the remainder will be 1 raised to 28, that is 1 only. So further, it is very simple. You can do the problem in even seconds. Now in this problem, 17 raised to 64 is divided by 288. Now we have to find out a number that is there in the power of 17 and which is closer to 288. So friends, 17 square is actually 289. So let's convert 17 raised to 64 in terms of 289. So it will be 17 raised to 2 into 32, that is 289 raised to 32. Now I have to divide 289 raised to 32 by 288 and I have to find out the remainder. So 289 raised to 32 can be written as 288 plus 1 raised to 32. So the remainder will be 1 raised to 32. So the remainder will be 1 only. Friends, if you practice well, you don't have to write even these steps. You can do it mentally since you already know that 17 square is 289. So it will be an even power of 289. So the remainder will be 288. The expression will be 288 plus 1 that you can do that you can visualize even in your mind. So the remainder will be 1 raised to 32, that's 1. Okay friends. Now what will be the remainder if 12 16 raised to 78 is divided by 9? Now let's find out a number which is closer to multiple of 9. So 1216 can be written as 1 2 1 5, that is 5 6 7 8 and 9. 1215 is multiple of 9 and it is 1 extra than that. So the expression can be written as like this. So now if it is divided by 9, the entire expression, all the terminologies will be divisible by 9 except 1 raised to 78, and that's 1. So if 1216 raised to 70 is divided by 9, remainder will be 1 only. It's very, very simple. Now in this case, 5000 cube is divided by 11. Now it's 5000 into 5000 into 5000. Now friends, what is the last number that is divisible by 11 and that is less than 5000? It will be 4994. Okay, so it is 6 less than 5000. So if 5000 is divided by 11, we'll be getting the remainder as 6. So the final remainder which I'll be getting is 6 into 6 into 6. So let's cut the numbers and get the final remainder. So 6 are 36. If 36 is divided by 11, we'll be getting 3 as remainder. That's since 33 is a number which is divisible by 11. That 3 which we obtained as remainder, that 3 into 6, that will give 18. If 18 is divided by 11, we'll be getting the remainder as 7. So 7 will be the final answer. Okay friends. Now we have to find out the remainder when 2 raised to 40 is divided by 9. Now we have to find a number which is closer to 9 and which is there in the power of 2. That's actually 8. Now 8 is actually 2 cube. But 2 raised to 40 cannot be directly converted to 2 cube pattern. So let's find a number that is multiple of 3 and that is below 40, that is 2 raised to 39 and 1 extra 2 will be there. Now 2 raised to 39 can be written as 2 raised to 3 into 13. This 2 will remain there. Now 2 cube can be written as 8. So the final expression will be 8 raised to 13 into 2. So now carry on with the problem. 8 raised to 13 into 2. If I wish to divide it by 9, so 8 can be written as 9 minus 1 raised to 13 into this 2 will follow. So if this expression 9 minus 1 raised to 13 is divided by 9, the remainder will be minus 1 raised to 13. So finally it will be minus 1 into this 2 will be there. So finally I'll be getting minus 2. Okay. So but the remainder cannot be minus 2. So the final remainder will be 9 minus 2, that is 7. So if 2 raised to 40 is divided by 9, the remainder will be 7. Now let's try this problem. 295 square into 296 cube into 297 is divided by 13. Then we have to find out the remainder. So 295 square can be written as 295 into 295 into 296 into 296 into 296 into 297. Friends, in the real examinations you don't have to write the expressions like this. Just for the sake of conveniency and for better clarity of concepts, I am just writing down the expression over here. Otherwise it's actually not needed. You can directly do the calculations over here. Okay, now 295, if it is divided by 13, the remainder will be, so I divide it over here. It's 13 2s are 26. 2s are 26. I get 3 and 5. So it's 35. 35 is 4 less than 39, which is multiple of 13. So 295 will be 4 less than the multiple of 13. So what I'll be getting as remainder, it's minus 4. So minus 4 2 times, since 295 square is there. Similarly, if 295 is 4 less, 296 will be 3 less. So it's minus 3 raised to 3 since I am having power as 3. Similarly, 297 will be minus 2. So now let's calculate the number of minus over there. So 2, 3, 4, 5 and 1, 6. So I'll be getting 6 times minus, that 6 times minus will get converted into a positive sign. So finally I left with 4 square into 3 cube into 2. Okay. Now 4 square is actually 16. If 16 is divided by 13, we'll be getting the remainder as 3. 3 cube is 27. If 27 is divided by 13, I'll be getting the remainder as 1 and then finally 2. So 3 2s are 6. So finally, if this expression is divided by 13, we'll be getting the remainder as 6. So in examinations, you should write only steps from this. You don't have to write this expression. Okay. I hope you are clear with the problem. Now, in this expression, we have to find out the remainder if the expression is divided by 11. Now we do it directly over here. So 125, the last number which is multiple of 11 is 121. So I'll be getting the remainder as 4. So it's 4 square. Into, similarly, 121 will be the last number, or we can say 132 will be a number which is divisible by 11. So you can take the difference, or you can add the extra number, whatever is your choice. So 127 will give the remainder as 6, and 6 2 times, so that is 6 square. Similarly, 133, the last number which is multiple of 11 is 132. So here I'll be getting the remainder is 1 square. Now it is 4 fours are 16. 16, if it is divided by 11, we'll be getting the remainder as 5. 36, if we divide 36 by 11, so we'll be getting the remainder as 3, and into this 1. So further it is 15, and 15 is divided by 11, so we'll be getting the remainder as 4. So the final answer to this problem is 4. Okay, isn't it so simple, friends? Now let's take this expression, 49 square into 51 cube into 52 raised to 4 is divided by 8, and we have to find out the remainder in this case. Okay, now we see 52 is actually a multiple of 2, and that is coming for 4 times. So definitely it is divisible by 2 raised to 4. 2 raised to 4 is 16. Now if it is divisible by 16, so it will be definitely divisible by 8. So in this case, we'll be getting the remainder as 0. So no need to calculate, just observe the question and do it smartly. Here I see one more type of problem. A number is obtained by writing counting from 1 to 64 side by side as follows. So what will be the remainder if this number is divided by 4, 5, 6, 8 or 9 respectively? In this single question, we have been asked 5 questions. So let's begin one by one. So if this number is divided by 4, we have to find out the remainder. Now what is the divisibility test of 4 that we have already discussed in our divisibility test session? I hope you'll be able to recall that if last 2 digits are divisible by 4, the number is divisible by 4. Or from there only we can find out the remainder. So if 64, these are last 2 digits, if these 2 digits are divisible by 4, then the entire number is divisible by 4. So we see 64 is divisible by 4, so we won't be getting any remainder except 0. Okay, so the first case is solved. Now what about 5? Definitely 5. For 5, we just have to see the unit digit. See the unit digit over here, it is 4. So if this expression is divided by 5, we'll be getting the remainder as 4 only. Okay. Now we are done with 4, we are done with 5. Now let's see of 8. What is the divisibility test of 8? The last 3 digits must be divisible by 8. So we have to divide 364, that is the last 3 digits, by 8, and we have to find out the remainder. So 8 4s are 32, that 2 and this 4, 8 3s are 24. So 364 is multiple of 8. So even in this case, this expression will be divisible by 8, so we'll be getting the remainder as 0. Now we left with 6 and 9. Now for 6, the number should be even and it should be multiple of 3. So the given number is actually even, so it will be definitely divisible by 2. Now let's check for 3 or 9. So we make a check for a 9. If it is divisible by 9 or whatever the remainder we are getting, on the basis we can conclude whether the given number is divisible by 3 or not. Just a moment, friends. Now friends, in my previous sessions, we have discussed about one or two properties of 9 that or we can say for odd numbers, that sum of 9 consecutive number will be definitely divisible by 9. So sum of 9 consecutive numbers will be divisible by 9, and the divisibility test of 9 itself is that the sum of digits must be divisible by 9. Here we see the counting 1, 2, 3, 4, 5, 6, 7, 8, 9 till the counting is going till 64. So definitely till 63. 63 is the last multiple of 9 below 64. So definitely till 63 the sum of digits will be divisible by 9, since sum of 9 consecutive numbers will be divisible by 9. So 63 till 63 there are 7 sets of 9 consecutive numbers. So definitely it will be divisible by 9. So we left with 64. Now what 64 will give the remainder if it is divided by 9? That is 1 only. So from 9 if it is getting the remainder as 1, now so finally we'll be getting the remainder as 1 if it is divided by 9. And now let's see this problem. This is an application of the concept itself. Here we have to find out the remainder if 1 factorial plus 2 factorial plus 3 factorial till 1089 factorial is divided by 6. Friends, the problem looks like a tedious and a very big one, but believe me, it's very simple. So let's begin. What 1 factorial is actually 1, 2 factorial is 2, 3 factorial is 3 into 2, that is 6, and 4 factorial is 24, and so on. You will observe that after 2 factorial each and every term will be multiple of 6, because everywhere in every term there will be 3 factorial which itself is 6. So from these cases we won't be getting any other remainder except 0. So the remainder which we are getting is from this expression only, that is 1 plus 2. So the final remainder is 3 only. So if this entire big expression is divided by 6, we'll be getting the remainder as 3. It's very, very simple. Friends, I hope you are clear with the concepts discussed in this session. We'll be doing some more problems in a next session. The problems which we'll be discussing the next session may be of some higher level also. But before going for the next session, I hope you will definitely revise the session. So all the best, and let's meet in the next session. Bye-bye.